Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about two processes, reversible and irreversible process. There are two irreversible factors, friction and temperature difference. Let's talk about the first irreversible factor, friction of mechanical motion. During the actual process, friction is unavoidable between the contacting parts that produce relative motion. Therefore, whether it is an expansion process or a compression process, something, no matter more or less, will always be lost, and there will always be an effect that cannot be eliminated. This effect is due to friction happening in the mechanical movement. A part of mechanical energy becomes thermal energy irreversibly, pendulum, and so on. Let's talk about the second irreversible factor, temperature difference of heat transfer. When an actual process proceeds with the heat exchanged, the heat is always transferred from the object with a higher temperature to the object with a lower temperature. When the thermal system absorbs heat from the surrounding, say object A, the temperature of the external object must be higher than that of the thermal system. And when the thermal system releases heat to the surrounding, say object B, along the original path, the temperature of the external object must be lower than that of the system. After a round trip, the thermal system returns to its original state, but it left an irreversible impact on its surroundings. The effect is that, due to the temperature differences existing during the heat transfer, a part of the thermal energy is irreversibly transferred from the object A with a higher temperature to the object B with a lower temperature. 2. Reversible and irreversible process. 1. Reversible process. A process that can be reversed without leaving any trace on the surroundings. That is, both the system and the surroundings are returned to their initial states at the end of the reverse process. This is possible only if the net heat or net work exchange between the system and the surroundings is zero for the combined process. Two familiar reversible processes, frictionless pendulum and quasi-equilibrium expansion, and compression of gas, are shown in figure. 2. Irreversible process, a process that is not reversible. Reversible process actually do not occur in nature. They are merely idealizations of actual process. Reversible process can be approximated by actual devices, but they can never be achieved. All the processes occurring in nature are irreversible. Why are we interested in reversible process? Two reasons that reversible processes are interested. One, they are easy to analyze, and two, they serve as idealized models to which actual process can be compared. Reversible process delivers the most and consumes the least work. The factors that cause a process to be irreversible are called irreversibilities. They include friction, unrestrained expansion, mixing of two fluids, heat transfer across a finite temperature difference, electric resistance, elastic deformation of solids, and chemical reactions. The following are three typical irreversibilities. Friction is a familiar form of irreversibility associated with bodies in motion. A very common form of irreversibility familiar to us all is heat transfer through a finite temperature difference. The unrestrained expansion of a gas separated from a vacuum by a membrane. A typical process involves interactions between a system and its surroundings, and a reversible process involves no irreversibilities associated with either of them. A process is called internally reversible if low irreversibilities occur within the boundaries of the system during the process. During an internally reversible process, a system proceeds through a series of equilibrium states, and when the process is reversed, the system passes through exactly the same equilibrium states while returning to its initial state. That is, the passes of the forward and reverse process coincide for an internally reversible process. The quasi-equilibrium process is an example of an internally reversible process. A process is called externally reversible if low irreversibilities occur outside the system boundaries during the process. Heat transfer between a reservoir and a system is an externally reversible process if the outer surface of the system is at the temperature of the reservoir. A process is called totally reversible or simply reversible if it involves no irreversibilities within the system or its surroundings. A totally reversible process involves no heat transfer through a finite temperature difference, no non-quasi-equilibrium changes, and no friction or other dissipative effects. This is an example for a reversible process involving no internal and external irreversibilities. This is an example for the totally and internally reversible heat transfer process. A reversible process must meet the following conditions. 1. The interior of the thermal system was originally in equilibrium. 2. The thermal system maintains a balance of forces with the surrounding when doing mechanical exercises. 3. Thermal system maintains thermal equilibrium with surrounding during heat transfer. Then a conclusion can be drawn. The reversible process is an internal equilibrium process without friction in motion and without temperature difference in heat transfer. In other words, if a process is implemented with quasi-equilibrium process and no dissipative effect, this process is a reversible process. Dissipative effect is the effects of work to heat by friction. Irreversible sources include unbalanced potential difference and dissipative effect. The reversible process is the ideal limit of the actual process. The reversible process does not cause any energy loss. Theoretically, the thermal power conversion efficiency is the largest. It is the comparison standard of the actual process and the goal to strive for close. The work and heat of the reversible process can be fully expressed by the state parameters of the working fluid in the system, making the calculation simple. The actual process is a complex, irreversible process. For the convenience of research, it is first processed according to the ideal situation, analyzed with system parameters, and then corrected by considering irreversible factors. Okay, that's all for this task. Thank you very much, and see you next time.